Hello everybody and welcome back. Today I'm going to do the 1998 FRQ number 3 from the AP Calculus BC exam, and I will explain my thought processes as usual. So first up, we are given, consider the differential equation given by dy dx equals xy over 2. On the axes provided below, sketch a slope field for the given differential equation at the 9 points indicated. So the way I was taught this, really simple. You just plug in each point and then you draw a small line with the slope you have identified. So for example, at 1, 1, we have x times y over 2 equals 1 times 1 over 2, which equals 1/2. And we remember this equals dy dx. So at 1, 1, I'm just going to put a slope that looks like it has roughly a 1/2 slope. And I'll just do this for the rest of these. And that is our slope field. So if we notice in the center, for x equals 0, we have slopes that are equal to 0. And on the right side, we have slopes that are becoming more positive as we increase our y value, which makes sense. And on the right, they become more negative as we increase our y value because our x value is -1. For part B, we are told that we can let y equals f of x be the particular solution to the given differential equation with the initial condition of f of 0 equals 3. Use Euler's method starting at x equals 0 with a step size of 0.1 to approximate f of 0.2. Show the work that leads to your answer. So for this, I've seen people do various setups where they make a table of x, y, dy, or nxy dy, something like that. But I think it's really just helpful to write out the formula to remember it, because it's a pretty simple formula. Just uses a basic format for an equation. So I'll write it out. That'll be y of n equals y sub n minus 1 plus the step size h times, and then f of x n minus 1 comma y n minus 1, where f of x comma n or sub n minus 1 comma y sub n minus 1 is the derivative of f at that point. And then I will make a table, and we are starting at x equals 0, so I'll just put that here with a step size of 0.1 to approximate 0.2. So I'll just write in our x values. So now, just working through these problems, at x equals 0, we are told that y equals 3. And now we are going to determine y for x equals 0.1. So we can write y sub 1 equals, and then our previous y is 3 plus the step size, which is 0.1, times the derivative at 0, 3. So that would just be 0 times 3 over 2, which equals 0. 0 times 0.1 is 0, so we get 3 again. And now for y2, we have 3 plus our step size 0.1 times, this time we have 0.1 times 3 over 2, which is 0.3 over 2. And now 0.3 divided by 2 is 0.15. And 0.15, let's just do these off out here. 0.15 times 0.1 is equal to, that would equal 0.015. And we are adding that to 3. So we have 3.015. So we can write out here f of 0.2 is approximately 3.015. And that is our answer for part B. For the final step of this problem, we are asked to find the particular solution to y equals f of x to the differential equation with the initial condition f of 0 equals 3. Use your solution to find f of 0.2. Right off the bat, we are going to just separate our variables. So we have dy dx equals xy over 2. I'll divide both sides by y, and I will integrate. So I'll be dy over y. The integral of that equals the integral, and I'll just factor out at 1/2 of x dx. And so this becomes the natural log of y equals 1/2 x squared over 2. So that would be x squared over 4 plus c. Moving on, we will get, and remember, I'm just keeping c on one side because technically we could subtract ac from both sides, but the c's of each side could be different, so we only need to include one c on one side. So now we can solve for c. So we have f of 0 equals 3. That means that if we plug in 0 to x, well, we're just going to get 0 squared over 4, which is 0. And if we plug in 3 to y, we are going to get the natural log of 3 equals c. So to isolate y now, I'm going to raise both sides to, or raise it as a power from e. So that means we'll get the absolute value of y equals e to the x squared over 4 plus ln of 3. Now, if you know your laws of exponents, you'll be able to realize that this is the same as multiplying by e to the natural log of 3, which equals 3e to the x squared over 4. And now we have y equals plus or minus 3e to the x squared over 4. But we know that this right here can never be negative because anything raised to a power cannot be negative. It can be really small, really close to 0, but it can't be negative. So we're going to have to remove this negative symbol and this positive symbol because we know y is just equal to that. So now I'll just write our final solution to the differential equation. We have y equals f of x, which equals 3e to the x squared over 4. And we are asked to find our solution to f of 0.2. So I'm just going to use my calculator for this. F of 0.2 equals 3e to the 0.2 squared over 4, which equals 3.030. Now, if you're not sure of how I was able to do that with my calculator, please check out my video on calculators, which I will link in the description. And that is the end of the 1998 FRQ number 4. I hope you enjoyed this video. If you did, please give this a like and subscribe. If you didn't, please share this video to somebody who will enjoy it. And I hope you have a wonderful day.